Hello, good morning, everyone. So today I'm going to present one of my natural language processing project, which I have done under Professor Vahid. So the title of my project goes as a generating abstract of the research papers, ARXIV using a pre-trained transformer T5 small model. That's a transformer type. Let me quickly go through the slides. Telling you about how the data processing is done, what are the database, and what are the models and what are the methods that I have used. So let me talk about the performance metrics tools library used, and what are the fine tuning, how I'm doing the fine tuning part, and what are the performance comparisons. Last but not least, I would also like to show you the demo part. So the core objective is to develop a text summarization model that can accurately summarize a research document. When I was looking for the kind of project, what should I do? Then I got one idea of why not to summarize or why not to extract the abstract from the research paper that are available. While I say the abstract, I mean to say the crux part of the document research paper itself. So I want to do that with my university research paper. I try to collect all the data sets from my university itself, but due to the limited data sets readily available from the university research sites, I choose to do the collab of the university available data and the publicly available data. But then again, there is a case of uniformity, and there is like some features that are not quite readily mapped, so that I prefer to choose the RXIV datasets from the Hugging Face. Also, I have used the pretend transformer T5 to perform the text summarization. I did the fine tuning of the pretend transformer model on the scientific papers, RXIV datasets, and at the end, I report the performance of the part. So publicly available datasets, as I had says, this is the Hugging Face datasets for this project, and this all datasets has been published in one of the paper or disclosure aware attention model for the abstract summarization, which also contains extracted text from the many scientific papers published in RxIV. Right, the datasets captures the features such as article and abstract. So is while saying the abstract is the not anything rather than the summarizing part of the article itself. So the whole data sets that is divided into trend, valid, and test split. They said that a number of samples in each split are the trend is about the 200,000, and validation is 6,436, and test data is 6,440. So this is about the data processing part which I have taken. And what are the models like? Talking about the model part, I found transformer architecture is a quite suitable for the text summary syntax. So the few possible choices that I try to implement are the GPT-2, Pegasus, T5, and BERT. But then I found that T5 is more reliable while doing the text summarization part, while working on the text part. As a T5 model has a different sizes, the large, small, and the medium kind of things, where I found like T5 model can be used for different size, and it also give me the leverage on the GPU, the resources that I have readily available. So I choose a T5 small model, and this is pretty good for me, a pretty good choice for me. So the T5 model, while talking about the T5 model, is a research by the Google researcher with a paper title "Exploring the Limits of the Transformer Learning with a Unified Text-to-Text Transformer." T5 model, also called a text-to-text transformer model. T5 numeric 5 is because it has a 5T for the first letter, like text has T, 2 has T, text has T, transfer has T, transformer has T. So it's a encoder and decoder architecture-based design for solving the NLP tasks like a text summarizations, text generalization, translations. Some of the fine-tuning tasks with a T5 is like shown there. So beside, like showing this for the last one with a blue color, like summarize state authorities. dispatch emergency crews Tuesday to survey the damage. This is the one that I have really tried to implement here, the with a small model and the text summarization part. So T5 models, what are the parameters for T5? It's a 60 million parameters, which is quite enough for my project, right? Though the training, I'm pretty sure that the training would take more than 12 hours for me to complete, but that's the only least possible options that I have. T5 is chosen for the project based on the resources time constraint. It has a 6 layer of encoder decoder compared to the T5, which has a 12 layers. The hidden dimension of the T5 is small. So as I said, right, T5 is chosen based on my requirement, where I have a list parameters, list resources, and GPU available. That is the reasons. Lastly, I try to do the training part in Google Colab, but I somehow could not do the training in Google Colab because of the resource constraint. And the Google Colab keep on breaking down after 3 to 4 hours, and even the Google Colab said that you cannot use the resources more than 12 hours, which has its own limitations. I did a lot of research, then I found options of using a Kaggle. Right now I'm doing the training part in Kaggle, but still the training part has not yet been completed successfully, but I'm pretty sure by the end of the next demo that I will be able to do that, right? So what are the performance metrics? Is the performance metrics is the ROG metrics that I have used. So we'll have the ROG 1, ROG 2, ROG 3, ROG-L, I'm sorry, ROG scores from 0 to 1. So it's a set of matrices, evaluates the quality of text summarizing the machine transformations. It has the also kind of concept of the n-gram with a continuous sequence of the n words. So that's a ROG matrix, basically is the performance matrix that I have. So some of the tools and libraries that I will be using is the PyTorch, Hugging Face Transformer, that's a T5 ROG scores for the performance matrix, NumPy for the general computations. Right. The fine tuning on the RVX status, pretend model is RVX status, and the article it's a document, and the abstract is summarized text is a target, right? So learning rate is 2 to the power 5. I'm also thinking of using some learning LR plateau, which itself has the in each after some epoch it will generate its own better learning rate. I'm trying to implement that, but let's see how that will go. As of now, the batch size is 16 and mixed precisions. That's true, right? Then the weight decay is 0.01. So that's like ROG score on RVX datasets using a pretend T5 model is computed, and also with a fine-tuned T5 small model. Both results are compared as the table below. This is still has to be done, but this is the latest metric so far I got, right? So when I do the fine-tune, the ROG scores increases for ROG 1, ROG 2, and ROG-L increases. So fine-tuned model has done comparatively very well on the ROG score measures, right? So before jumping into the demo part, let me also give few of the citations. As I have said, the data sets, right, model and GitHub Collab research. These are the few citations that I took the reference of, right. Let's jump into the small model. Model. I'm saying while saying the model, it's a demo part, right? So I already load the Google Colab part over here. Let me just quickly go through this. The demo part has been, done with a rogue score NLP. I have already get the all the weights over here. Install the dataset transformer rogue scores in the first part. The Gradio is the one that I have used for the demo out here. I could have used the Flax, but still, I better prefer to go with the Gradio because it's easy and readily available. Then after I did the mount of the mount, that means I connect the with the Google Drive, connect to the all the fine tune metrics of the model with the help of Google Colab. It's all over here, right? So I do have the project folder where I can get that. This is the training part that I am thinking of doing it. Let me quickly show you out here what are the things I have, right? So these are the sample data SCSV file and everything's over here, right? So moving forward, I have imported some of the libraries that I need, like NumPy is a NP, Pandas, PD, random, OS for the file management, torch for the tensors, tenses and when disables is equals to 0. This is like the file transferring from one drive to another drive, right? That's true. So for the reproducibility, common practice to set the number of seeds at the possible seed is equals to 100. So I have used this code with the help of CUDA, right? Then we need to install one git lms, make the version of the transformer at least, and functionality was introduced. Importing the transformers, then the fine tuning the small model, loading the database, right? So after this is the one that I have started doing the training part, but it will definitely take time, and there it has not been completed so far. Let me quickly jump to the demo part real quick. Here also I have to the and mount the drive. Then after I connect with the weight that has been already calculated, I imported some of the libraries over here. Also the sample data set over here, like if we see the sample data set, it said that this is the article and this is the abstract. These are the sample database I have. These are the few models. I downloaded all the things over here. Now moving that this is for the Gradio app. Moving forward, okay, now you can run this part in over here or over the local host. Let me run through the local host. So when I see go to the local host, then I can choose the database over here. From there, is like I can choose any of the. This is just a name: row one, row two, row three. So document is this one, right? So document is this one. This also gives the target summary. We do have the target summary, and we do have the generate. Let's generate. It will take at least 8 seconds to generate the data part. Oh, it is taking more time. See, and whatever the target, whatever the whatever target, the target is like this, and whatever we have generated is this one, which is clearly seen that better than the the better than the model that has already been done. So our generated task is this one, right? Even we can try with any of the text summarizations. You can get anything from here, like. Uh, News today. Let me quickly copy some of the news from here, and let's see how our system works. Let me copy paste any of the news over here. Um, okay, so if I copy paste this part, put it in here, then if I say generate, it will definitely generate the summarized text from here. The city plans to distribute this one. So like this, it is working. So that's all from the demo part. Thank you so much. I took a little more time, but that's it.